All right, I'm going to go one step back from where you wanted us to be. I'm going to assume that you've managed to do part one and you're up to part two. Now, with part two, they're saying that x cubed equals 12x minus 8. They're saying that. And they're saying x is 4 sine theta. So 4 sine theta cubed equals 12 4 sine theta minus 8. So 64 sine cubed theta equals 48 sine theta minus 8. So we get up to that point there. Now, when you get to that point there, you can actually divide everything by 8 and end up with 8 sine cubed theta equals 6 sine theta minus 1. And when you divide everything by 8 again, you get sine cubed theta equals 6 on 8 sine theta minus 1/8, which means that sine cubed theta minus 3/4 sine theta plus 1/8 equals 0. Now, what's interesting about that is when you look at the top here, sine cubed theta minus 3/4 sine theta plus sine 3 theta on 4 equals 0. So this bit here that I'm putting the rectangle around, sine cubed theta minus 3/4 sine theta, that's the same as, if you come down here, this bit here that I'm putting the rectangle around. And you're like, oh, okay, so I'll replace what it says. I mean, this is saying that sine cubed theta minus 3/4 sine theta actually equals negative sine 3 theta on 4, isn't it, if you rearrange that equation? So I'm going to replace it with negative sine of 3 theta on 4, that rectangular bit, and plus 1/8 equals 0. So, sorry, I just need to make a bit more room here, and I need to scroll down. So, I can't quite get below. I'll just insert a couple of page breaks so that I've got some room to work, and I'll end up back up the top. There we go. So I end up with that. So basically, sine of 3 theta on 4 is equal to negative 1/8. So sine of 3 theta equals negative 4 on 8, which is negative 1/2. All right. Now, what does that mean 3 theta could be? Well, yeah, I agree. 3 theta could be a whole bunch of things. For example, to be negative 1/2, you could be, if we just, let's take the positive answers for now, you could be in the third quadrant. Now, the basic angle for sine theta is 1/2 is 30 degrees. So pi plus pi on 6 is 7 pi on 6. And 2 pi minus pi on 6 is 11 pi on 6. Then you would need to go to be negative, you need to get round into these quadrants here, right? So you would need to go all the way around to 3 pi plus pi on 6, which is 19 pi on 6. And then 4 pi minus pi on 6. So that's 23 pi on 6. and so on and so on and so on. There's any number of solutions, right? Now, if you divide by 3 here, you'll get theta is 7 pi on 18 and 11 pi on 18 and 19 pi on 18 and 23 pi on 18. And the list would go on and on and on. And you're like, well, how do I know when to stop? Well, when we're looking at solutions to this original thing, they've asked you back up here to let x equals 4 sine theta, right? So when you use your calculator to work out which ones of these give you different values, for sine of 7 pi on 18, is that different to 4 sine of 11 pi on 18? Is that different to 4 sine of 19 pi on 18? Is that different to 4 sine of 23 pi on 18? You need to decide sine of which things are going to give you different answers, because they're the ones you want. So say 7 pi on 18 is one you're going to take, right? 7 pi on 18 is about here, right? In terms of spinning. So 4 sine of that is going to be a certain value. 11 pi on 18 is here, right? It's going to give you the same value when you do 11 pi on 18 or 7 pi on 18. So I've already used a value that's going to give me the same thing for x, because x is 4 sine theta. 4 sine 7 pi on 18, 4 sine 11 pi on 18, same thing. We'll get back on here. 19 pi on 18 is around here. So that's going to give us a different value. So I can use that one. 23 pi on 18 is about here. So that's going to give me a different value as well. Now, remembering that this is a cubic, so a cubic can only have 0, 1, 2, or 3 answers. And I've just found 3 different answers. So I'm happy just to finish it up there with those 3 answers. Now, I've found the answers for sine 3 pi is minus a half. 23 pi on 6. Right. Okay. The next thing is, so they asked you to show that that equals that. That's fine. Now I've found my answers there, and what I'm going to do is then look at roots and have a look at, like, if I've got my equation x cubed, sorry, I'm just going back up to minus 12x plus 8 equals 0. Then I know that the sum of the roots of that is minus b on a. And actually, you know, I could do myself a favor here and just write it out with its full amount. So I could actually write out that this is plus 0x squared, and then put in minus 12x plus 8. The sum of the roots is minus b on a, right, which is minus 0 on 1, so it's 0. The roots taken 2 at a time, whoops, alpha plus beta plus c. I'm doing some unusual things, aren't I? Normally you'd call that gamma, so I'm going to do that. And beta gamma, that would be c on a, which is minus 12. And alpha, beta, gamma would be minus d on a, which would be minus 8. And then this is the bit that I think, because they've got squares, I think they've squared some of these things. So I think they've found like alpha squared plus beta squared plus gamma squared, which we know is the same as alpha plus beta plus gamma all squared, but minus off 2 alpha beta plus alpha gamma plus beta gamma. Now, I don't know if that's the bit you need explaining or not, but I'm going to assume that you know that relationship there, that if you get the 3 roots and add them up, their squares up, it should equal that, right? Now, the 3 roots themselves, we just found were, and if I go back up, 7 pi on 18, 19 pi on 18, and 23 pi on 18. So, sorry, I need to get rid of that. All sorts of things happening here. 7 pi on 18, right? Sine of that squared and sine of 19 pi on 18 squared and sine of 23 pi on 18 squared, right? That is equal to the sum of the 3 roots, which we found was 0, minus twice the product of the 3 roots, which we found was minus 8. Right? So sine squared of 7 pi on 18 plus sine squared of 19 pi on 18 plus sine squared of 23 pi on 18 is equal to 16. Right? Now, when we go and look at what they've got something close, but not quite there, right? They've got sine squared of pi on 18, 5 pi on 18, and 25 pi on 18. All right? Pi, 5 pi. So I'm just going to write pi on 18, 5 pi on 18, and 25 pi on 18. All right, now, the point here would be that when you square a negative, you still get a positive, right? And if you just look at this, you'll go, all right, sine of pi on 18 is there, right? And sine of 7 pi on 18, sorry, 19 pi on 18 is there, right? Pi on 18, 19 pi on 18 are related, aren't they? Like sine of pi on 18 is the positive and sine of 19 pi on 18 is the same thing, but it's negative. But if you were to square them both, they're the same. So I'm saying that you can replace this guy with sine squared of pi on 18. It doesn't matter because whilst they're the same size, they're different signs, but you're squaring it. And then look at the next one, 5 pi on 18, right? So that's just around here. It's just under 6 pi on 18, 5 pi on 18. And 23 pi on 18 is the same as here, the same place, but round here. It's like 18 pi on 18 plus 5 pi on 18. So those two values of the 5 pi on 18 and the 23 pi on 18 are going to, when you do sine of them, they're going to give the same size, just different signs. But if you square it, it's not going to matter. So that there is going to be the same as sine squared of 5 pi on 18. And so we've done the pi on 18 and the 5 pi on 18. So we're hoping that 7 pi on 18 and 25 pi on 18 are at a very similar place. And it's true. 7 pi on 18 is about here. And 25 pi on 18 is the same place but here. So sine of 7 pi on 18, sine of 25 pi on 18 are the same size, just different size. But if you're squaring it, it doesn't matter, right? So I can replace this one with sine squared of 25 pi on 18. So when I add those three together, I still should get the same amount, right? Which I'm saying is 16. Now, obviously, I've made a little error because they're telling us in the answer that the sum of the squares of those three things is 3 over 2. So I need to look more carefully at what I've done here. X cubed minus 12x plus 8. Let me just here, x cubed minus 12x plus 8. The sum of the roots is minus b on a, which is 0. Minus 0 on 1. Yep. Taken one at a time is c on a, which is minus 12. Yep. And taken 2 or 3 at a time. Yep. So I've got these things correct. Next thing I need to do is go, all right, did I get the square of each of the roots, alpha squared plus beta squared plus, and the answer is no, I didn't write them down properly. And now I'm looking back here and I'm going, reduce, because each root is x equals 4 sine theta. 4 sine theta. And I only wrote down sine theta down here when I did it. Alpha squared plus beta squared plus gamma squared. I should have been putting a 4 inside each of these. I'll just get a different color so you can see what I mean. I should have had a 4 in there, a 4 in there, and a 4 in there. So each of those should be 16 when I square those, right? Each of those should be 16. So I should have got 16 that, 16 that, and 16 that. So then, because I'm squaring each of those, but that equals to 16. Well, then that would equal to 1, but I'm 3 on 2. So now I need to look more carefully. It's alpha squared plus gamma squared, beta squared plus gamma squared is alpha plus gamma minus twice alpha beta plus alpha gamma. And there, I put an 8 in there. What a goose. Look, it should be minus 12. So I should have put minus 12 in there. 2 times minus 12 is 24. So there we go. I should have got 24 there. And remember, each of these has a 16 in front of it. So I'll just write it more neatly. We got 16 sine squared 25 pi on 18 plus 16 sine squared pi on 18 plus 16 sine squared 5 pi on 18 equals 24. So let's divide everything by 16 and we get sine squared 25 pi on 18 plus sine squared pi on 18 plus sine squared 25 pi, just 5 pi on 18. And that equals 24 on 16, which is 3 over 2, isn't it? Which is what the answer was. Now, in order to stop this recording, I go up here and press pause.